In section 6.2, we compare the properties of strong typicality and weak typicality. First, we give a quick summary. Weak typicality requires that the empirical entropy is close to the true entropy. Strong typicality requires that the empirical distribution is close to the true distribution. We are going to see in proposition 6.5 that strong typicality implies weak typicality. That is, if a sequence is strongly typical, then it is also weakly typical. We are also going to show that weak typicality does not imply strong typicality. Both weak typicality and strong typicality have AEP, but strong typicality has stronger conditional asymptotic properties, and this will be discussed in theorem 6.10. It is also important to note that strong typicality works only for a finite alphabet, but weak typicality works for any countable alphabet. Proposition 6.5 says that for any sequence x of length n, if x is strongly delta typical, then x is weakly eta typical, where eta tends to 0 as delta tends to 0. The proof follows directly from the strong AEP and the definition of weak typicality. The formal proof goes as follows. If x is strongly delta typical, by property 1 of strong AEP, we have the probability of the sequence x lower bounded by 2 to the power minus n times entropy of x plus eta, and upper bounded by 2 to the power minus n times the entropy of x minus eta. By taking the logarithm and multiply by minus 1 over n, we have minus 1 over n times log of px, that is, the empirical entropy of the sequence x, lower bounded by entropy of x minus eta, upper bounded by entropy of x plus eta, where eta tends to 0 as delta tends to 0 as asserted by the strong AEP. Then by definition 5.2, we see that x is weakly eta typical. The proposition is proved. Now we are going to show that weak typicality does not imply strong typicality. This is done by the construction of a weakly typical sequence which is not strongly typical. Consider a random variable x with distribution p such that p0 is equal to 0.5, p1 is equal to 0.25, and p2 is equal to 0.25. Note that p1 is equal to p2. Consider a sequence x of length n, and let qx be the relative frequency of occurrence of symbol x in the sequence x, where x is equal to 0, 1, and 2. In order for the sequence x to be weakly typical, we need the empirical entropy to be close to entropy of x. And we are going to see how to choose the relative frequency qx to make this happen. First of all, the empirical entropy is equal to minus 1 over n times log of px. This is equal to minus 1 over n log of the product k equals 1 up to n p of x sub k, which is equal to minus 1 over n summation k equals 1 up to n log of p of x sub k. Now this summation is equal to the number of occurrences of 0 multiplied by log p0 plus the number of occurrences of 1 multiplied by log of p of 1 plus the number of occurrences of 2 multiplied by log of P of 2. This can be further written as minus the number of occurrences of 0 divided by n log P0 minus the number of occurrences of 1 divided by n times log of P1 minus the number of occurrences of 2 divided by n times log of P2. Now, using the definition of Qx for the relative frequency and also the values of P0, P1, and P2, we can write this as minus Q0 times log 0.5 minus Q1 times log 0.25 minus Q2 times log 0.25. Now we want to make this close to entropy of X, which is given by minus P0 log 0.5 minus P1 log 0.25 minus P2 log 0.25. That is minus 0.5 log 0.5 minus 0.25 log 0.25 minus 0.25 log 0.25. Thus, we have to choose Q0, Q1, and Q2 such that the values of 1 and 2 are close to each other, which in this case can actually be made to be the same. Note that we have log 0.5 here, log 0.5 here, log 0.25 here, log 0.25 here, log 0.25 here, and log 0.25 here. Obviously, we can make 1 equal to 2 by choosing Qi equals Pi for all I. That is, Q0 is equal to 0.5, Q1 is equal to 0.25, and Q2 is equal to 0.25. Now notice that P1 is equal to 0.25, and P2 is also equal to 0.25. And so we have log 0.25 here, and log 0.25 here and here. We have seen that we can make 1 equal 2 by letting Qi equals Pi for all I. Alternatively, we can choose Q0 equals 0.5, Q1 equals 0.5, and Q2 equals 0. Q0 equals 0.5, Q1 equals 0.5, and Q2 equals 0. With such a choice of Qi, the sequence X is weakly typical with respect to P because 1 and 2 are evaluated to exactly the same value, which implies that the empirical entropy is close to the true entropy, which in this case is exact. However, the sequence X is obviously not strongly typical with respect to P. Because Q, the empirical distribution, is not close to P, the true distribution. Specifically, we have Q1 equals 0.5, but P1 is equal to 0.25, and Q2 is equal to 0, but P2 is equal to 0.25.